Hello? 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 This is how you do it. Hello? 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 Can you hear me? Hello? Can you hear me?
Hello?
Hey, Jacob, how you doing, man?
I'm doing well.
Can you I'm using Teams right now, but like I usually use Zoom. But like, do you hear echo?
I did when I first joined. But
Okay. What about now?
no.
So okay, so you can hear me good, right?
Yeah.
Okay. Awesome. Okay, so like, yeah, how's everything? I know we're supposed to do the thing today, but like I earlier today, but like I was caught up with like driving.
Yeah.
Yeah, like I usually live in LA, which I'm back now, but I was out in San Diego for like an appointment, like for like the whole entire day. And then the drive is like usually 3 hours, so it was like going there and back.
Gross.
Yeah. Okay. So let's see. So like I did take a look at like a few of the problems that like on your review. It looks very similar. So I think that's a good thing.
Good. I think I printed it out.
Okay. Let me see if do you see my screen?
Yeah.
Okay. So what I ended up doing is I'm gonna see if I got up to like homework 3, and I did take a look at homework 4 and 5. Uh, those aren't that bad, but which ones are you feeling less confident on? Maybe you can focus on those.
I would say 3.
3.
Yeah.
Okay. Let's focus on those. Because like 3, I think isn't that bad. Um, I would think like 4. and 5R, but let's I did actually do here. If you look over here, because like that's just the pretty much the basics of me, taking an integral. So this is really nifty because then I can just share like this program. Okay, so like I did do problem one. Did you for the quiz or like the homework that you guys did?
Yeah.
And did you get through those, or like do you understand the homework problem?
What is that? Okay.
So you do you hear an echo?
I think my printer's going off.
What is it?
Okay.
Is it good now?
Yeah, that's good.
Okay. So yeah, like one of my best like things is like you just have to do it, and then the more you do like the integral, like the more you can practice the techniques, right?
Right.
Yeah. But like, okay, do you understand this problem though? Maybe we'll tackle this one, or this is a homework problem, and then we'll look at the review.
Well, there we go. I found what I was looking for.
Okay. Okay, so this problem, uh, maybe you can tell me first like what you would do, and then I'll like kind of guide you if that's what you would do for this one.
Well, wouldn't you just do U substitution for the bottom?
Yeah. Technically, it's just like you either have, like I think a lot of the techniques is like treg sub or like U sub, and then integration by parts.
Right.
Yeah. And then like so for this one, a lot of it is just if you're using like a fraction, and then you know that there's this really complicated fraction that's like an x squared. Your choice of bet is really just U sub. So yeah, you're right. That's what the first thing you would do. And I did take a look at like a few of these for homework three, and what it is really is like a double U sub, which I feel like your professor is like, because the way I learned this, then what they tested us was just like, can you do the base like one U sub, and that's it. So it's kind of brutal. Okay, so I guess the very first thing here is like knowing this problem, you would first do like a U sub, and then but like you have to figure out like what are you subbing for. So sometimes it's not very clear. Like like this part right here is what you're gonna sub for, but then you have to go through all these steps and see like this U right here is where I'm getting this guy from.
Oh,
Does that make sense? That part right there is like, okay, what like why are you using x for 4 secant equals times 4 times secant u? So and then like looking at this problem, like you wonder, it's like, oh, how did you just know that? So I guess my first question is for for your professor, like how is he testing you guys? Is it gonna be fully online?
yes. It'll
And
be
then
fully
like
on.
is he gonna be monitoring it, or is it just like, okay, go ahead and then send it?
It's proctored, so I would
So
think
he is
so.
gonna be there. Okay. Okay. So like, cause like this usually takes a while. And how long? What's the time limit for the exam?
Hour and 30 minutes.
30. Okay. Okay. Cause like I was gonna suggest, I always suggest this because for my like students, like it it takes you a lot of time to figure out like what to sub for. But have you heard about Wolfram Alpha?
Yes.
Yeah. I would probably, because that's a good guidance to have. It at least narrows down your choices of directions. So like, for example, like this problem, I'd probably just like input like this exact problem and then kind of just follow, and then because for this one it's literally you have this x and then this 4 secant u. The reason why you're doing this is so that you can actually simplify it, like that integrand to this guy. And in order for you to do that, you do have to sub in for this u equals secant inverse x over 4, and then do these manipulations. Mainly, like you have to do these manipulations, and then this right here is this guy. There's a lot of Treg manipulations, but do you understand at least this part? Let me just see.
No, not really.
Okay. Yeah. So like, if you were to be given x equals 4 times secant u, you understand why we got the how do we got the dx, right? This part right here.
Which part? I can't.
Like after you get the here, can you after
Yeah.
you after you get x equals 4 times secant u, then you need to get this dx. Do you understand how we got that one? At least that part.
Yeah, that's just the derivative for secant, right? It's just
Yeah,
tangent times secant.
yeah.
But
So
it's
like
like,
that's technically like just the derivative of this guy, the 4 times secant u. So that part you get.
yeah,
Like,
but it's like,
okay.
where did you get the secant?
So that's the thing. Like a lot of these like integrals with Treg
Uh-huh.
substitutions is really like a trial and error, because and then that's why it takes a long time.
Oh, okay.
Yeah, like so if you have Wolfram Alpha, at least it will guide you to, narrow down the choices.
So that's what they mean by trig substitution.
Yeah, that's Treg substitution. How strong are you with your trigonometry?
It's been a bit.
Yeah, a lot of the integrals, like it's, I mean, I would say maybe like the calculus one where you did like derivatives. It's it's less used in derivatives but more used here because you're doing a lot of Treg subs. And then like the way you would attack it is very I would say like sometimes it's not as obvious. Like for example this one, it's not obvious, right? Like how do you know x equals 4 secant u? But you do need to do that though. Like if you were to attack this another way, I don't think it will work. So this part right here, after you get x equals 4 secant u, that's the reason why we're able to get this u.
Right. Okay.
Yeah, and then the next step after you do that, like accepting that okay, that's the way to go. After you do that, then you need to manipulate this, like the original equation you have,
Right.
to like you already have an x and you already have a dx. Just manipulate, and then this is the manipulated version. That part you get though, right?
Yeah.
Like, okay, and then what I had here was just a simplified constant. Then probably the harder part is this guy. Now you have to simplify secant cube u over 10 to the fourth u. And that took quite a while. Though I was trying to figure that out. I was like, what Treg properties do I need to use so that I can get to this point? So again, it's like a lot of this is just like you need, if you have like a sheet, have your Treg properties at hand, then that'll be good to have that, and so that you could just like, okay, which one do I need? And then so one of them is this guy, 10 to the fourth, right? Which is this guy, sine to the fourth u over cosine 4u.
Right.
Yeah, because you could either use the this guy, but this doesn't really help us. It's rather like this is the guy that helps us. So a lot of Treg properties is just that, like which they can go in like a lot of rabbit trails, but you need to know which one to substitute. Okay, so you have that 10 for, and then the other one. See, the other one is this secant cube u equals 1 over cosine cube u.
Right.
Yeah, that one, that one's like one of the easier ones. And so you pretty much just sub that to like what you have here. So that's what I did here. And then, 1 over cosine u times the inverse. You get this guy. Cosine u over sine to the 4. It still doesn't look that good because the way you want to simplify like the integrand is the goal of it is you want to you want to remove the fraction, right?
Right.
Yeah, you want to make it so that it's like one liner in a sense. So we still have to work on this guy. So what I was thinking was, and then a lot of it is just like manipulation again, so that you can recognize like a Treg function. So what I did is like, I left the numerator, but then the denominator I put sine u. I split sine u by itself and then sine to the cube u. And because this one I know is cotangent u, right? Cosine u over sine u.
Yeah.
And then this other term, 1 over sine cube u.
Just cosec.
Yeah. So now you have it as a one liner. So that's really good. That's probably the hardest part. Like everything else is just doing the integram, like integration. So this part right here, and then so this is just me like writing again. And then so that's like your first u sub.
Okay.
And then the next thing is, okay, how do I get this to so that I can actually solve for like the integration? And then so the way I would do it is substituting these guys. So this is the next one. And then this is just manipulating it. And so after you do like another substitution, you have to manipulate your integram so that you can actually get something from it. But yeah, like I said, if you have Wolfram Alpha, they'll show you some of these. If you just so that for the difficult integrals, because it will take you a lot of time. Honestly, if you spent like days trying to figure out like, oh, like what path should I do, what use should I try, use subs. I think for like other ones like Treg substitution and use subs take a longer time, but if you do like integration by parts, that one isn't as like prone to like like different ways of doing it, but this one is which is gonna cut your time for the exam. It's not because like you don't know how to do the like, the concept, or you don't know the concept. It's just that there's just so many different ways that it could happen, and I'll show you that though. But you said you weren't familiar with Wolfram.
No.
Okay, I'll show you that after a few of these, so that like it makes sense. Like how does it really narrow your like integration? Okay. So after that, the second u sub is this guy.
Just
You're just
regular
gonna get
integration.
this guy. Yeah, it's really easy, and this is what you want, because then you don't have any more Treg functions, right?
Yeah.
Yeah. So you do that. You know that one. This one's not that bad. And then at the end, this is always the system. Like after you do a bunch of u subs, is you plug them back in
Right.
one by one. until you get this guy. So yeah, does that one make sense at least, like the concept?
Yeah, I mean, it's gonna mess with me about like the whole guessing and trying thing for the trig part.
Yeah, but I wouldn't like the way, because like I did, knowing how students usually go about like with this, it's so much better if you put more effort in like the integration by parts and doing that really fast. And then
Hmm.
for this one, I'll show you that the Wolfram Alpha, and in that sense, like much of the effort is not so much on thinking about the different directions, because it does cut up your time. I know this one takes a lot of time. Okay, so let's take a look at these problems. All right. Actually, did you want to do one more homework 3 problem too?
Um, yeah.
Okay. I haven't had a chance to do that, but let's try. Did you do some work on that one already? Like, did you get an answer?
Let me see.
It's very similar though. Let me just look at it first. And we can probably just do it right here.
Okay.
Yeah, this one is a definite integral, so or maybe this is a perfect time for me to show it too. Here. Let me stop sharing this one. All right. Okay. Let me know when you see this.
Yeah, I see it.
Okay. So like this is Wolfram Alpha. Yeah, you're gonna have to. I did say this. It's not fully free. Like when you go to his website, it's like wolfram.com. Yeah, it's like $6 or $7 a month, and for the semester, I think it's like 33 for the semester. But like let me just show you the capabilities first, because if you were to do this by yourself, like this U sub, it will take a lifetime on your sub. Um, but like so this is our problem, right?
Right.
So all you have to write in here is like, okay, you want to do an integral, and then just type in whatever in whatever way, and then it'll spit you different things in here. Like some of these doesn't is very irrelevant, but the first one, it'll choose, it'll rank them the way that you're trying to figure out the problem. So this is what we want, right? Let me just put it. If you want just like a indefinite integral, you just do that. But you can actually put in a, a definite integral from doing it from 4 to 7. And see, it gives it to you, right?
Yeah, I see it.
Yeah. But then the best thing about this is this guy, step by step solution. And if you hear right now, it's not really okay. Yeah, sometimes it does. I just do this one first. Come on. Anyways, it's not showing you, but it should. It'll tell you over here. It's a little bit cut off. But if you do this one, it'll give you all the steps, and even like this is the part that you probably want, the u, right?
Yeah.
Like u equals x minus 4. So if you follow these steps, it'll give you the because most of these are going to be double u subs. So if you put like if you assume both the first u and the second u, then you'll get the answer, and then just plug in plug in your like integration limits. And I think that's to cut the time of actually solving these problems. I would probably do that for the U sub ones. Or once you recognize that, oh, it's a U sub problem.
Okay.
And then for like integration by parts, how do you feel about that one? Like I think that was like homework 2.
The ultraviolet voodoo one. That's all I remember really.
Yeah. Homework 2 isn't. Let me see. Let me just go to it. These are like kind of like the one-liner one with like you have like two things being multiplied.
Yeah.
Those are usually like that's how you recognize it's like integration by parts. Like there's two things being multiplied, and there's no it's not always the case, but 90% of the time there's no fraction. Do you want to go over that one, or I think I did all of homework 2.
Yeah, let's go over that one.
Okay, let me stop this one. Let's see. Yeah, we'll go over those and then let's look at the review ones. Okay. All right. So for that, okay. Homework 2, problem 1. So for this guy, there we go. Let's get a good one. Okay, so for this one, what would you like? I guess for this one, since it's not that bad. What's the first thing you would do? And then, I guess let me ask, like, so do you know how to recognize like problems if they're U subs or integration by parts? If because it usually doesn't tell you.
I mean, usually with integration by parts, it's like two different functions.
Okay. Exactly right. Being multiplied.
Yeah.
Yeah. And so yeah, in this case, that is true. And then for U subs, what is it? Or like treg sub?
I would think it's most of the time it looks like division.
Exactly. Yeah. So yeah, that's for 90% of the time that's the case. Maybe like certain situations, like I think number 3. Yeah, number 3, homework 2. You have like a division. Okay. So knowing that, so we have this equation, right?
Yes.
Yeah. and then this is a definite integral. So yeah, it's gonna be u dv from a to b equals u times v, like evaluated from a to b minus the integral of v du from a to b. So it's pretty much just like doing this, right? Like the essence of a integration by parts is just doing this part,
Yeah.
and hoping that and then I think the one tip for these that makes it easy, or like it could be complex as well, is your choices of u and v, or like dv, because you always choose those, and then you just you integrate the u to du, and then you or you do the derivative of u to du, and then integrate dv to v. And then what I would say is like the one that you choose for u is the one that you want to it's usually a polynomial, or because you want to reduce it, right? You want the goal is to make the integral so that it's just one function, not two functions anymore. Like the t, you want the t to become like either a constant, and then that's usually the case. So if you were to choose, I think u as like the sine function, you it's just gonna keep on, because that's a trend, that's a trig function. So it's just gonna keep on cosine to sine. But if it's a d, if you and then if the polynomial is the dv, you're just gonna increase, right? Because it's gonna increase your power.
Right.
So for the most part, I would choose a u that's the polynomial, because the u is the one that's gonna decrease in power, because you're deriving, or you're taking the derivative of it, which is right here. So that part you get though, right?
Yeah.
Okay. Yeah. So a lot of these, like the ones that your professor gave you is multiple. You have to apply the integration by part twice or three times, and so you have that, the u, and then du, and then dv and v, and then right here is just using that equation. And then so this first part is the u and the v, and then this part is the v, and this is the du. And so for these, it's not that bad. I would say just be organized with, like, because with you know the part that's not, like, the one that will confuse you most is this minus sign. And then because this minus sign uh, will kick you if your integral, this v du, is like negative as well. So what I usually do is I just put the negative inside the integral, so that it actually it gets carried in the, like, all these u and dv's, so that you don't miss like a negative sign. And then this negative sign in the integration by parts is always going to be there, so that it doesn't, like, always keep this constant as a negative sign, and then everything in the integrand here, the vdu, if there is a minus sign, just carry that with you, like in the evaluation. And so yeah, it's just this guy. Like, you just do the pretty much the steps. But this one, do you get the steps?
Yeah.
Okay. Yeah. So mainly with these is like bookkeeping, knowing what's already, like, been evaluated and not an integral anymore, and then just keeping your signs for that integral consistent. So this is what I usually do. Like, I try to categorize them, and then for each of these, like, I like, I evaluate them as groups, and then in the end I just put it together, so nothing is missed. And this is pretty much the answer. And then again, the basic stuff here is like your trig has to be strong. So how do you feel about this?
Okay, yeah. I get it.
Do you think this one is like medium in difficulty?
Yeah.
Okay. What parts like I guess for the integration by parts I, it's somewhat a breeze. It's just pretty much like applying the equation, but is there something in it that like you think is like harder than doing other things, or do you pretty much get all the different aspects of it?
I'm trying to see, because it's the
Okay.
second part that gets me.
The second, you mean the second like application of it?
Yeah.
So this guy.
Yeah.
Okay. So after applying it for the first time, um, what I would do is so you already have this the one in the box in red. That's the UV, right? So that one you just leave alone.
Okay.
It's and it's this guy that we're gonna do the next integration by part. So you know that part right here, you have the u, the cosine. This is the u. Shoot, no. So this right here is the u, and this one is the dv. And then again, you have to make a choice. Like, which one do you want to make u, and which one do you want to make dv? Always, right?
Right.
Yeah. Hold up, I kind of missed that one. So that choice right there is up to you. For the most part, I always want to make like what I did here, like the polynomial, the u, and then the trig function as the dv. Does that make sense?
Yeah.
And then what's the reason for that?
Because the trig function is just going to switch back and forth.
Exactly. Yeah.
It's never going to get simpler.
Yeah, and then that's like the goal is to make the integrand simpler. So okay, so that's what happened here. The you go with the steps, take the derivative, take the integral, and then so this one just carries down. The other one is second u and v that you evaluate, and now the v
I
du.
get it.
You
I
got it
see.
now.
Yeah, I get it. I was wondering where you got that.
Okay. Awesome. Okay. Yeah, and then you look at this. It's already there's a constant here. There's no like variable now. And that's the goal. So now you only have to evaluate sine and now apply integration by part. So goody. Okay, so you got that one.
Yeah.
Okay. Let's look at this next one. This one isn't like that bad. You think that you don't even have to apply it here, right?
Yeah.
Yeah. So I was like, a little surprised about this. It's like, oh, like it's only. I mean, I think it's just you can just do the lnx, but when I looked at this in Wolfram, like it made sense because the, oh yeah is your professor asking you guys to use like the tables? Can you or do you have to prove that like the integration tables? I think it's in the back of your book.
I haven't heard anything about it.
Oh, okay. So everything is derived. Yeah, you cannot use any like pre-solved integrand or integral.
No, not that I know of.
Okay. Okay, let's not because like for us we had that chance. Like if there's like an integration table that's already been solved, you just work at like okay getting that and then you can sub for it. Okay.
Okay.
So for this one, it's kind of similar. And So I guess for this, I'm like, what's the most obvious u is like just this guy,
Right.
and then this dv. You don't have to always have like the dx can directly be the dv. In this case, yeah, that's what happened. And then the reason why you want this like u to be the ln x, the most obvious, is you're gonna get this like if you apply ln this chain rule here over x, and then the goal is let me see how many times you have to apply this on. Oh, it's only once. Oh no, once here and then the second time. So the second one is a little weird. So let's look at it. So now this is already evaluated, and you have this next udv that you have to evaluate. You have to get the perform the integration by parts again. And so this part right here, don't get confused. This is just me like simplifying it. It's not another term. So you have this minus. So this is my trick every time, is like you want to make this like plus, like right here.
Okay.
Like that's before you apply the integration by part. Because if you keep this minus out, you're gonna get confused when you apply this negative here at side, right?
Right.
Yeah, and I never want to put that like negative and think, oh, is it a positive? Is it negative? I don't want to. And then so that to make the mechanics easy, I always before I do the integration by part, um, in the beginning here it's already positive, so that's easy. But the second time you do it, and it's gonna be up to you how you do it the second time. And my suggestion is always make it plus, like for the grouping, and then put the integrate the subtraction sign symbol inside, and then just carry it through here as I did. So there's like no mistake. Okay, so for the second integration by part is, if you look at this, you have minus 2 ln x dx. So my thought would be, why don't we just continue doing what we did here? Because we went from like this ln x squared as the integrand in the beginning. Now it's a ln x, right?
Yeah.
Yeah. So I guess we did we made something happen. It reduced a power at least. So that why don't we just keep that being as the u? So that's what I did here. And then the rest of it can go into the dv. And then so you did this, and then you did that, and then you apply it again. So here, hold up. So this, okay, just to explain this part. Um, this right here is from the first integration by part, and then this right here is the evaluated one, the uv from the second, and then this is the vdu.
Is there an X right next to that -2? Or
Oh, this one or this one? This one?
the red one? Or like the second of the red one?
This one, right?
Yeah.
Yeah, it's uv, so it's minus 2x ln x. It's just this u and v that we
Oh
have.
yeah, that's right.
Yeah, the uv, yeah, from the second one. And then the reason why is because you took the integral here of v. And that's a 2x. Okay. So now, like, again, like, there's a lot of these minus signs. So that minus sign from the integration by part is this guy. And then our v du, which we carried out the minus sign, is this guy. And so v du, so minus 2x is v, and du is 1 over x dx. And then it just simplifies there. This becomes 2x. So with that would be our I kind of just simplified it like here because I saw that there's an x that they have all in common, and then for the exam or like any other, like if that one a time that you always get evaluated is never forget the C. Like it's been a while since I did something like this, but uh, not now I remember. I say, oh yeah, every time you always have to have a C. Even if everything you did was like right here, if you forget the C, it's definitely wrong.
Right.
Yeah. Okay. Do you understand that one? This one isn't that bad.
Yeah, no, that was pretty
Yeah.
nice.
I think the reason why it's integration by part is because you have this squared.
Yeah.
Yeah. Okay. All right. I think this one is the one I don't like. Every time there's always like a substitution or like a trag. It always gets like really complicated. What do you think of this one?
Uh, I, I guess there's a sine cubed.
You want to do this one?
So can we do this? Can we like take out a sine?
For this guy?
Yeah.
Yeah. For this, like it's one of those things again. It's like, what route are you gonna take? It's like, I it's a question that I really hate asking because it could go many ways. But like because this manipulation right here, the reason why you're doing it is so that you can get this guy right. The sine squared x equals 1 minus cosine squared.
Yeah.
So let's see. Let me see if you can use Wolfram Alpha for this one. Oh yeah, you can always use Wolfram Alpha, but let me see what it says. So sine x cubed divided by cosine x to the 1/2. Yeah. So yeah, like every time you have to do something, this is what they do as well. Like you would have to like do this so that the reason why is so that you can actually get the sine x by itself in order for you to do like a u sub. And I think you're gonna do another one. This is kind of this is actually this is not like an integration by part. Yeah, this is a u sub and treg sub. That makes sense.
I disagree.
Yeah. How did you do this one?
Well, I started by failing at it.
And then what route did you take?
Well, I mean, I tried doing parts, but
Oh,
it
you did
didn't help.
integration by parts. Okay.
I tried.
Okay. Did you do this on? Oh, actually, like, if you can show me, that'll be good. But how? Like, what's the first thing you did? Like, what was the U and the V?
I tried making cosine u,
Just the cosine.
and then the dv I made sine, or sine, well, cosine of half. But
Did you get somewhere with it though? I mean, before we tried to do that.
oh no.
Like, what was the end? Yeah, because like a lot of it, maybe you could try to do that, but like I think that's something that would probably prompt us is if it is a division, it should be like a a U sub. I thought first it was like an integration by part, but this is a division. Because if you did, let me think. If you did like a U sub, or like a UV, like a integration by part, you both of them are trig functions, right?
Yes.
That's the part that's gonna be like tricky because how do you simplify them? Like how do you get like one function out of it at the end?
You do not.
Yeah, it's like if you do like I guess two things, like if it's a fraction, um, try to do like a U sub first, and then like all hell breaks loose, like just do like integration by part. But for the most part, it's always like a U sub, and then like if there's no polynomial at all, it's most likely not like it's most likely a U sub. If there's no polynomial, like both these are trig functions. But yeah, like, I guess if if I were attacking this in the exam, I would probably put these as the last thing to do, and then just attack the the easier integration by part problems. But like for this problem, does this make sense though? Like this part at least.
Yeah. Well, except the last one.
Okay, so this is me simplifying it.
Yeah, I
It's
get
cut off. It's a little cut off. Let me just which problem is this? 2, 3.
Let's see.
I
So
think this is the one. Yeah, it's a little cut off. Here's the full one actually. This guy. So this is the one, right? I subbed it, and it's simplified.
yeah, that makes sense. Yeah.
Yeah.
I just didn't see the full picture.
It's very weird, like how because a lot of it is just playing around with the trig functions, and then so now you see this part. Like, how do you get u cosine x? Why did you do that? Because if you mess with there's two signs here. There's two signs, and then so you could do this. You could factor out the sign, and then you're left with this cosine x and then another cosine x here. And then what I tried to do here is knowing that I want to sub for cosine. And then I need to know I need to find a term that matches the du. And then the du for this is minus sine x dx. So like I don't see that here. Like, initially I don't see that here. So I have to create that term to pop out somewhere. So that's why I had to manipulate it from here to get this guy. And then so that's that minus sine x and dx. And then but the trick with this one is this problem wasn't we initially didn't have this minus sign. So you have to add another minus sign.
Okay.
I know it's really weird, right?
Yeah.
I honestly don't like this problem, but you have to put up with it for this exam. Like it is what it is. Like it's you need to look at the problem and then like what can you manipulate for trigs, and then what can you sub for? Those back and forth questions is always like gonna bite you. But so you do that, and after you do the U sub, first time you get this. And then you have to do another one. This one makes sense. The next U sub.
Yeah. Give me a minute. I'm just writing it all down.
Okay.
Okay. Yeah.
Yeah, these ones are pretty bad. Like you just have to do more of it. The system, at least the system itself for like for an exam like situation. Do you guys get like partial credit?
I think so.
Yeah, like what I would do, I like well first of all like definitely get Wolfram Alpha
Will do.
because at least you have like because what it gives you are the steps, yeah. But then if you don't like even if you don't buy the full like pro, you get like the final solution, and then so you can just fill in the blanks.
Okay.
So you got this one.
Okay. Let me see. So we did that. I'm trying to refill.
Which part are you in?
I'm at the -2 integral of 1 minus w to the power of 4 over 2u to the half du.
This guy. Okay.
Yeah.
Yeah. For this one, it's just let me see. So when you go from this guy to this guy, you have to because the u that we have is this one, or like the w in this case. W equals u to the 1/2, and then when you look at the original one, like there's no u to the there's only one u to the 1/2, right?
Hmm.
So we're trying to get this u squared. So I would just look at like you have a relationship between these two already, and then you could make this a u squared. So you just times two times 4. So that's what I did. Like or raise it to the power 4. I meant,
Right.
and then this one raised to the power 4. This becomes 2. So now you have w to the 4th equals u squared. It's really iffy, but I was like, you have to do that. And then now you got this guy.
And then u turns into dw, and then you can integrate that. I get that. Okay.
Yeah, and then this part right here is it's always after you get the W, you need to manipulate. It's not very straightforward every time. You need to manipulate your original equation so that you can plug in a DW for the next.
Right.
Oh wait, what's going on? That's probably why. You know when I was showing you Wolfram Alpha earlier,
Yes.
like it was being weird. It wasn't showing you the full step. Like try not to use like Chrome. So if you were to get it, like use like anything but Chrome, and then I'll show you like here. Maybe I'll share this. Do you want to see this done in Wolfram?
Yeah.
Okay, let me just because I have to switch the screen. Let me stop that one. And okay, let's do this. Okay, let me know if you see this.
Yeah, I see it.
Okay. All right. So this is what you do, right? Integrate and then the function. And then
Yes.
so you click on step by step. Well, first of all, like if you don't click on that, you'll get the full answer. This is not the answer I put though, because you'll see why in a bit. Let me just make this bigger. But what's nice about this is it gives you like step by step. So yeah, obviously first step taking the integral, and step two, for this integral, use this drag identity. So this is what we use. I mean, this is like your typical, sine squared plus cosine squared equals 1, which is what we did. And then you have to manipulate it. The nicest thing is it gives you, what you assume, and then like what you should do. Not every step. There's times when it just tells you what to assume, which is already good enough. Like, and then it's up to you to figure out, like, how do you manipulate the integral to get to that point? But it's nifty, right? Like at least it gives you this thing.
Yeah.
And then step 3, so you have this now, the integral, and then it's time to do like the u sub. So like they chose to do cosine x, and then so see right here, like it doesn't show you, right? Like you go from this guy to this guy, and it gives you this view. It's up to you to figure out how they got that.
Right.
Which isn't that bad. If you could like do that for the exam, like figuring that the sandwich, like the step in between, it's easier than like going on a rabbit trail.
I mean, with DU, what they would have told you to do in Calc 1 was just solve for the dx by taking the negative and dividing it by du, or just -1 divided by du, and that's how you would get that set up.
Yeah, you could get it set up. Yeah, there's many ways. Yeah, you could do that. But like, yeah, if you do it that way, yeah, that's still good. The way I did it was just so that you can best, it works out. So as long as you make it work out, it's good.
Cool.
And then the next thing is they give you the second u sub. And again, like, yeah, this is the previous. They give you the next assumptions, and then the result.
Yeah.
So it's not bad, right?
Yeah. No, that's good.
This is really like good. Like this is like one of those tools that if you were to take the test online, you could do this on. And then like for the time that you have, because it will cut your time like more than half for this problem. Because it's just like doing the algebra, right?
Yeah.
You're pretty much just solving for the algebra in between. And so after that, like once you have this, I think this is good enough already. You can just not use, you can skip the rest and just do it on your own, like after this guy. But just to show you, uh, what they do is they plug in all the U's that they subbed for. They got this, but then they show you like this very complicated like form of it, which I don't suggest you should do because like it would be too, like I guess for your professor, like how does he or how do they want you to like present your answer?
Knowing them, probably the most complicated way possible.
Okay. I guess do they care what the integral answer is, or do they just care if you did the integral properly?
I would think that they care for if you did the integral properly.
Yeah. I mean, the ending part is just like it's not really the calculus. Like for example, this part to this guy.
Right.
Yeah, I mean you're done. Calculus is done there. You're just doing like algebra or trig. But yeah, I just I'll show you how you would do that. Like you know when you go to wolfram.com.
Yeah.
Here, if you just go wolfram.com. I guess let me sign. Let me sign out. Okay, so what I would do is like, so this is the thing you see. I would probably click on upgrade to pro, and then just look at like, I guess for students here. Why is it not showing up? Here we go. Here we go, and click on Go Pro now. Pro is the one that you want. Here you go. This is the one I want. So like here you have annual, semester, and monthly. I would probably just go to like semester, and it's really cheap. If this one would click. But yeah, anyways. That's Wolfram Alpha.
Seems very convenient.
Definitely, yeah. Like it helps out, especially just for that part. Everything else, I would think you can do at a certain like degree of like skill, but that just takes. It's not skill at all. It's more like you have enough time. Okay. All right. So I guess yeah, we went over a lot of the. Oh, actually, did we go over the last one? Maybe we should go over the last one, and then we'll talk the review. Okay. Did you do this one too? The homework 2, problem 4.
No, I don't think I did.
Okay. This one isn't that bad. I guess just to go over it, it's not that like. It seems like you would do like an integration like by parts, but because we have track functions here, you don't want to do that because for the same reason again. Because if you do like a u v or u and bv, like it's just gonna keep on repeating. So like the default here would be okay, do a u sub because you have track functions, even if you have them multiplied. So the u here would would be just the x over 2, and then the du, like it would be like 1/2 dx after that, and then you manipulate this guy, and I think the one thing is here is like to get rid of this Streg mess is to do the Streg identity. So tan squared u cosecant squared minus 1. And in order for you to plug that in, though, you have to manipulate this again. So what I did here was tan u. I split this tan to the 5th, to tan u, and then tan to the 4th. The reason why I did that is so that I can get this tan squared inside here. So like, just a strategy, like, okay, tan squared to the squared. So that's what I did. And then here, you just plug this in.
Yeah.
And so that's the result of the first U sub with the treg sub. And then you do another U sub. And this time you're gonna want to get rid of the treg functions. So for example, this one. Uh, so W. For looking at this guy, I decided to do, for the next one, the secant one instead of like tan U. For these reasons, you could attack it another way, but this is what I did because the derivative of secant, you're gonna get secant and tan, which is very convenient. So this guy going to this guy, uh, and this you ask yourself again, okay, how do I want to plug these back in? For this case, you don't have to manipulate anything really, because you already have like your parts. You have the W here, or no, not the W. This right here, and then this guy is a DW, and then this one is the W, and let's see, and then this two was what we had, because of like the first U. And then yeah, from there you pretty much just you can just solve this now. And plug everything back in. So this one wasn't that bad, right?
No.
Okay. All right. I guess so. We'll look at the review. How do you want to attack this one? Like, did you want to like do some of the problems, or have you started already?
No, I just got that today.
Yeah, I know. Like, okay. Um, which ones? Like, I guess for the, let me see. For these ones, how do you feel about? We didn't really cover these ones, but how do you feel about? I think it's like chapter 12.
I think the AE plus like use figure to sketch the following vectors.
Oh, this guy.
Yeah.
Okay, so how I would look at this is like you. Let me just see. Did your professor give you guys like the solution at least?
Yeah, we have the solution. I can.
Oh yeah, maybe we can go over that. I think it'll be better rather than like shooting in the dark. Let me just see, and maybe we can like talk about it. There's questions. All right, you can share.
Yeah, where does share content?
Does your professor give you like give you guys the solutions for everything, or is it just some?
Yeah, no, it's everything.
Everything. Oh wow. Okay, good. All right. I guess let's look at that one, the one that you were talking about. Okay. Let me see. What was the question? Okay. Okay. Using the figure to sketch the following vectors: A, E. It's just like drawing the addition, right? It's just
Yeah.
drawing the addition. Yeah. Do you know how to do that? Like the draw. It's like geometric addition. Uh, like if you have two vectors, what's the vector? Draw the vector of the addition of it. What I would do is you could do it two ways. You could have the AE, like if the AE. Go back to the solution.
Okay, so it's just like from A to the.
Yeah, it's pretty much the A, like AE, and man, if only they write like the same thing, because it's usually just the two vectors in between. You project one, and then you connect it to the other, and then it should be up to that point is what you draw. But then they share that same point, which is A, I think. Yeah, or no. So you have AE. Let me look at this first. So AE, and then you have
EC.
EC. Yeah. So AE and EC connect the ends. The A is the one that's being shared. So AE and then EC, and it's just from A to C. Yeah, I think that makes sense. It's usually that's how you add it. You just connect the two vectors like where the ends are.
Yeah, that's it.
This one's an easy one. Okay. What about the 10? Let me look at number 10. Negative 1/2 BC.
BC.
So BC.
So it's
It's
just
just
half
one
of
half
that.
of it.
Yeah.
Yeah. I honestly like. Do you remember doing geometry? Like I honestly hate geometry too.
It has been a bit.
Yeah. It's kind of like that. Like I don't know why. Like usually, I don't remember getting tested. Like if I know how to draw vectors in calc.
He was like, usually we focus on this at the end. We're going to focus
Yeah.
on it at the beginning.
That doesn't make sense. Why? Because it's so easy.
I guess.
Yeah, because like it's usually if we have time, like because the bulk of integral calculus is all the different techniques and then I guess the word problems that where they apply. That's usually what that is. How I remember it. And then like calc 3 would be like multivariate and all these vector stuff.
I
Okay.
guess it's important to him.
And it's like different, different folks. So okay, what about 11? Tell me how you would do that one. That's kind of similar to 9.
C. And then AE. I mean, isn't that the same? Or
It
isn't
depends on like where they're going. Is it like you have A going like for 9 you have A going to E and then E going to C. But this one is C going to E and they're meeting at E. What's
oh,
the problem? What's the solution?
would it be to C to what? Would it be to C to A? Or
Yeah, if you were to draw this one, yeah. Because like how I would do it is I would get the C and E, and then you have this, and then draw the A to E,
yeah,
like on top of that, and then just connect the ends.
right.
Which is like C and he gives you C to D. So he gives you C to D, and then so C to E, and then A to E.
Oh,
C to E, and then A to E. So when you connect the ends like from beginning to end, for example, like A to E, right?
yeah.
For number 9, for number 9, looking at number 9. I'm wondering if you can actually let me see. Yeah, I can request control. Can you approve that one?
Let me see.
Maybe I can mark this.
What do you need me to approve?
I work.
Oh, allow.
Usually, what I do in Zoom is okay. So you approve that one? Okay, good. Let me see if I can draw on your screen. Usually, I'm not so familiar with this one. But do you see my mouse?
Yeah.
Okay. Okay. I'll just draw with my mouse. So, anyways, um, A to E, right for
Hmm.
number 9. So you start with A. That that's the tail. Oh no, I guess the tail and then the head, right, where the arrow is.
Right.
And then
E
E
to
to
C.
C, that this is the tail and then this is the head, right?
Yeah.
So you connect the tail to the head, the tail of like the first vector to the head of the second vector. But you always have to draw it that way.
Okay.
Okay, so explaining 11. So you have C to E, right? So tail from
Hmm.
at C and then head at E, right?
Mhm.
And then, but A to E, this is the problem. Like A to E, now you have the tail here, and then the head here. So you want to redraw that one, and you usually do it the same way as how you had 9, where you draw the tail of the second at the head of the first. So C to E, and you move that one here, right?
Yeah, so now it's just E to D, or it would look
Exactly.
like that, and then you would just connect C to the head, which
Yeah,
would be
that's how I
C.
remember it. Like it's like a weird rule, but you just have to do that.
Okay.
Okay, what about 12?
What is 12? DC, but it's subtracting.
Let's see.
DE.
So for this one, if I remember it, because when you're adding it, that's what you do. But then when you're okay, it depends on like how you draw it. So okay, let's see. D to C. So let's see. D, tail, and head. C. Okay. And then so minus B E. B. Is it to here? So we have D to
BE.
C. Is it this guy?
Yeah, no, wouldn't it? Because don't you do head to head with subtraction?
Yeah. Try to go to the solution. It makes more sense if we just like couldn't do that. Oh look, it's right. Okay, let me try to explain that. So that is the one. But so you had a C to D or D to
Hmm.
C, D to C, and then this B E
Hmm.
is negative. So I think it's the negative of it. You go over here, right?
Yeah.
And so you draw this guy, and then so it's this one. You just connect it.
Yeah.
That all makes sense.
Yeah.
Okay. And 13 is pretty much the same, but then now you have to do the 1/2. 1/2 is just cut it in half. Like it's like A to D. A to D would be 1/2 of that would be like DE. Sorry, A to D. It would be this guy because it's negative.
Right.
It's the other one. It's not this guy.
So it'd be E to B would be the
Yeah. Try
resulting vector.
try look at it like B D
Oh, yeah.
BD
Yeah.
and B to E. Yep. And this guy. So it has to be the one connecting. So yeah, it's pretty much like what you know, and then connect that to what you connect it to that vector.
Okay.
And it's different. I would probably practice more of the subtraction one. The addition one is like fairly simple. Okay, so that one isn't bad. What about like so? What about like 1 to 8?
I'm pretty sure I got these down here.
Yeah,
And
this one's kind of like the like you've probably seen this before. Not in this class, but somewhere before. Like equation of a sphere, and
yeah.
then unit vectors, component, and like yeah. Okay, I think for the bulk of it is the I think he gives you a lot of like integrals to evaluate, right?
Yeah.
Yeah. So yeah, you want to like do one of these, or because like I was thinking like maybe I can like do these. He already gave you the solutions, right?
Yeah.
Maybe it wouldn't be that much. Does he give you like every step?
No, I think he just gives you the answers.
He just gives you the answers. Okay. Which ones do you feel like kind of murky on? If you had the chance to look at it. Like looking at this, I feel like for this one is integration by part.
Yeah.
This one's a sub. This one's a sub. Integration by part. This is a sub. Yeah, the sub ones, or like the ones maybe we should practice.
This one, maybe.
28.
Yeah.
Let's look at the answer. Actually, let me plug this in first and see what we get. Let's see if it gives you the right thing. X squared plus 1 times x squared plus 2. And, okay, let's see. Okay, I got something. Okay. What was his answer?
Uh, he does give you the way to do it.
Oh, that's good. He doesn't like okay, he substitutes. Oh wait, like I've seen this form. I've seen this technique before.
It's a lot of
It's like
ABCs.
yeah, like when you sub for he does it that way. Okay. And let me just compare the answer. Let me see. 3/2 ln x squared minus 3 tan inverse x. Oh, it's exactly the same. The answer is exactly the same. But like,
Oh, he does it in two ways from the looks of it. No, wait.
what's like the let me say A3. I think he just found the A's. This is the coefficients. I wouldn't do it that way though. You know how like he got the coefficients?
Yeah,
It's
I've
I
tried
think
this.
partial fractions. This is the partial fractions one. Like I mean, you could do it partial fraction integration. You solve for like the constant, you know, the A's to these. But the way I for integrand use partial fractions, term factor out, factor two, integrand, and then do the U sub. They do a U sub. He didn't do a U sub for this one. Yeah. Do you understand the way he did it?
No.
Okay. Let's take a look at this one. So 2. Okay, let me just show. Maybe I'll show you how I would do it. There. All right. Okay. So like, I guess you want to do this with me.
Yeah.
So like, first thing you would do is let's write this down. I guess. And x squared. Yeah, you do have to do the partial fractions. Plus 2 dx. And then so wow, that's a lot of steps. So you know how like he solved for like the A's to D's. I, what I would do is you need to change this into a form. Well, I'm gonna show you the result first, and then I'll show you how I would do it. So you need to get to this point where you're like changing it from that to this guy. And it's dx, obviously. But to get to this point, from here to here, is like the way of the partial fraction. So that's the method. And this is how I would do it. So the first thing is, so you have this guy, right? And you would have to change it so that you have like, let me see, b plus ax over like x squared plus 1. It's just the form. Did he show you guys like how to do this? Like a partial fraction method?
Yeah.
So x squared plus 2. You know how like you have these bottom ones right here?
Mm-hmm.
Like you split them. You put them, you split them into, and then the the top is where these coefficients pop out. And it's usually like a linear. It's usually a linear function. And then so it's just like mapping it. Like it's like you have this integrand, but then you want to change it using partial fraction. And it, like the mechanics of it is knowing these two things, you split the denominators, and then the numerators is just linear functions of these like coefficients. So that part is like just the concept. You have to change it that way. And then the harder part here is solving for these coefficients. And then now the next step here is you don't want to be working with fractions. You want to get the LCM, and then multiply it by that. So what I would do is just multiply. Here, hold up. Let's put this in a form where it's like easier to read. There. Plus 1, x squared plus 2. Okay, here you go. So you want to equate these two. The reason why is because we're going to be solving for these coefficients. So what I'm trying to times these is just this guy. Because you want to get rid of the fractions. So you times it, both sides, and then you're going to get, obviously, let's see, I think it's ax. X squared plus 1. Oh, wait, no, x squared plus 2. X squared plus 2. Then b x squared plus 2. Does this make sense so far?
Yeah.
Okay. And what I would do here is do this for now. D plus C X. And then pretty much you're just going to simplify. So you get something. So let's see, 2B. Which is from this guy. And this one plus D. And X cubed. Where are we going to get an X cubed? Okay, so this guy. And then this one. So let's see, that's A plus C X cubed. And then X squared. X squared would be from B and D. B and D. B plus D. X squared. And then X. Everything else that's left. Okay. So you have that. And now, so you have 4 unknowns there, A to D. And then you want to form like 4 different equations so you can solve for these. So let's see, let's make the first one first. So that's 2B plus D. So this part you probably know how to do, right? Like you just pretty much equate this guy to this one. Like where these, terms are from left hand side and right hand side. 2B plus D. And then so these are for like the constants. So I'll just do this one. Constant. This one is for the x's. This one's for the I think the x cubed or x squared rather, and then x cubed. That's 2A plus C. Let me see that. Oh, yeah, that's right. Yeah, 2A plus C. Okay. Then minus 1 B plus B and 3 A plus C. Okay. Does that look right?
Yes.
Yeah. This part is like pretty much all done. Like kind of like algebra stuff. Then you could technically from this point you could use your calculator. Or does he want you guys to show that part?
I imagine he wants us to show it because he's gonna have us submit the paperwork on WebAssign.
Yeah. Like if solving systems, you could use a matrix. Are you comfortable with that?
I haven't done matrices in a while.
Okay. When you're solving systems, what form do you usually do? Like a method, I meant. Like the sub, or just solving it directly like this?
Yeah, just solving it directly.
Okay, we could do it that way. The matrix way is like so much simpler, but let's do it that way. Okay. We'll get the same answer, but see. So you have 4 things happening, just so that we get like the right answer. Like it's supposed to result as this. So A is supposed to be 3, B is -3, C is 0, and then D is 2. That's the end goal. So let's see, -4. Actually, hold up. You could usually take these guys. 6 2A plus C and 3 A plus C is minus it. You're gonna get minus minus. You get 3 equals, and this is A. So here you go, that's the first one. And then let's plug that back into it, to one of these guys. 3, and then so is it 3 plus C. This cancels. So C is 0. That's good. That's done. Okay, and then this guy, now I do these two. -4 equals 2B plus D. A -1 equals B plus D. And let's do minus this guy. This cancels. +1 +1. Minus A -3. And it's B. Okay, there you go. B is good. And then let's see. -1 -3 plus D. +3 +3. So that's 2 equals D. Okay. Did you get those ones?
Yes.
Okay. So okay, that confirms that. So now, see, like that part is just all the partial fractions. That's the method, and then now you're gonna plug those back in. You're gonna plug all. Oh, hold on. You're gonna plug all these coefficients back to this guy. Let me make this. Okay. Can you still see it?
No.
What about now?
Sort of.
Maybe I should have used a thicker one. I didn't want to smudge it, but okay. Let me just write that fraction, and now let's start out with something thicker. Okay. So after you get all those coefficients, you can change your integrand to this guy. +2 equals 3x minus 3, x squared plus 1, plus 2 over x squared plus 2, right?
Yes.
Okay, and now you pretty much integrate. After I would probably simplify it like this. So 1 over x squared plus 2 dx, split them, and then 3x minus 3, x squared plus 1 dx. And then you want to do a u sub. So like it's like this. Like you gotta manipulate it first though. So 1 over 2 plus 1 dx plus 3x minus 3 x squared plus 1 dx. And then so with that you can cancel this guy. So for this one, like for this first part, You could u sub. Let's see. I would probably choose this part. So this problem is like probably the hardest one because after you do like partial fraction, you have to do a u sub. So it's like this guy. So let's see. So if you do that, you do it correctly, it's gonna show up like this. Like only for this one, this first term. And then so does that make sense?
Where'd you get the square root of 2?
So okay, so that part is the one we have to explain. Okay, so there's u here from this first part. I guess let's look at it. So this right here is so you have 1 over x squared over 2 plus 1, right?
Mm-hmm.
And then so this u though has like x over root 2. So you times this by root 2. And then you put so that you only have x. Because this right here, this x is x over root 2, right? Squared. And this is your u. This is your u.
Okay, I see.
You got it?
Yeah.
Okay. Yeah, it's just like all of that kind of stuff. Anyways, the reason why I guess the reason why we're doing this first of all is do you recognize this term?
Point at it.
Huh?
Which term?
This one. Ah man, why is it so light? It's crazy. Let me do that again. This term.
Yeah, it's the same one as above, right? Well,
It's like a
sort of.
treg, right?
Yeah.
It's a treg function. Yeah. So this one is this crazy like treg functions. Is that guy, right?
Yeah.
Yeah, like the treg is sometimes gonna kill you or help you. So after you do that, you know, it's not like whatever. It's this thing. It's this thing. That's actually that guy. So you solve one of them, and then you're still left with this one. So yeah, I would probably attack it that way, like do it one by one. That's the reason why you could do the partial fraction, so it splits it, and you can attack the integral that way. So now you do the second term. So here, I was gonna rewrite this again, but you would want to simplify this. So just factor out the 3. There's like x minus 1 over x squared plus 1. And then, so this now, it's going to look weird first, but like there's a reason for it. Let's split this actually. I'm gonna leave this so that I don't have to keep on rewriting it. There you go. And let's just do this guy. All right. So for this guy, you need to like in order for you to solve this one, you need to expand the integrand, and then before you do it, like a u sub. So like this is how I would do it. All right, look. Hold on, let me see. Maybe I'll show it that way. So this is the integrand x squared plus 1. Like you want to split it. It's pretty much the same thing, but the integrand is easier to solve if you do it this way. X over x squared plus 1 dx. And then the 3. You have the 3, right? So minus 3, 1 over x squared plus 1 dx.
Wouldn't the
Which one?
second, the net minus 3 times the integral of 1 over x squared plus 1, isn't that just tangent?
You mean this guy? Or 1 over this guy?
Yeah, they both are, right?
Yeah, the 1 over x squared plus 1. Yeah, tangent inverse, right?
Yeah.
Yeah. You could do it that way, yeah. Like we're gonna get like I'm just filling in the steps so that you can do like a u sub.
Right. Okay.
Yeah. So, but it will become a tangent inverse. So, let's just do that first. So for this one, like let's do just for this part. I was gonna do like a w equals x squared plus 1, and dw equals 2x dx. So that one becomes 3 halves 1 over w. And then the second part is still the same. 1 over x squared plus 1 dx. So this part right here is like, it's just the integral 1 over some like an x or a w. That one's an easy one. That's just log or ln. So that's that part. And then the second term, let's work on that one. So yeah, as you said, right? This one is just tan inverse. So I would probably just do like 3, and then tan inverse 1 of x. So here I would plug back in what you had, so that you have like, because you already have this term as x. So it's going to be 3 halves log x squared plus 1 minus 3 tan inverse x. So you're almost done. So this was that second term, right?
Yes.
If I can anyways. You remember the first term. So this is this guy, and then we have this other guy. So let's put them together. Get another color. So that's gonna be root 2 tan inverse of u plus 3 halves log x squared plus 1 minus 3 tan inverse of x. This guy still has u, so let's plug that in. So the u, if we remember, was x over root 2. So it's root 2 tan inverse x over root 2. and then, you know, and I think that's what we have right in the end. I think that was the solution. Minus 3 tan inverse x. Kind of similar to that. Whoops.
Yeah. Well,
there you go. That I don't know why I'm running out of. I didn't think it would run out of ink. Yeah, so that's how you do it. And then don't forget the C. Plus C. Does that one make sense?
I'm trying to... In the answer, they have 2 over root 2.
Let me sit down there. Let me start showing this off. It's probably just an algebra thing.
Is it?
Let me think. 2 over root 2. Yeah, it's the same thing, right? Like
Yeah.
Root 2 over 2. 3 halves ln x squared plus 1. Okay, which is a log. Same thing. Minus 3, and then x over root 2, and they had 2 over root 2, which is supposedly 2 root 2 over 2, right? Which is just root 2.
Oh, okay.
Yeah. What about how do you feel about the partial fractions?
I'm iffy on them.
Okay, is there another one like this? Let's look at another one. Like, it's really not bad. It's just the mechanics, like the step of the step.
I don't see another one.
There's actually a lot in the book. Let me. Is that another one? I think I saw
24.
Yeah. Okay, let's look at that one. Let me input that one first. 24 before you. Let me see. So that's x squared plus 8. 8 times x minus 3 divided by x to the cube plus 3 times x squared. X squared plus 8x minus 3x cubed plus 3x squared. Okay. Okay, we can do that one. I guess for this one, do you want to try maybe explain like how you would do it, and then I'll do it after.
Okay. So
There's always some value in trying to explain it, and then because that's the concept, and then finally the how. Like, okay, let's do it. So what's the first thing you should do?
should we try to simplify the bottom at least, like trying to pull out an x, so we can
Okay.
have it in the AB form or whatever that is.
Yeah, you could like it's kind of similar. You want to like simplify it so that you get two functions in the denominator, right?
Yeah.
So what would it be? Like what two things would you have? Just like looking at it, it seems very easy, right? You're gonna have an x squared.
Yeah.
Okay. Let's try to do that first. So I'm gonna do that right now. X squared plus x minus 3, x squared. X cubed plus 3x squared dx. All right. Simplify. It'll be x squared plus 8x minus 3. Factor out x squared, x plus 3. Okay, so did you get that one? So it would be over x squared times x plus 3.
Yeah.
Okay. What's the next step?
Now would the b plus ax be over x squared, or
For partial fractions?
yeah?
Um, okay, so with this one, let's look at how he did it first. Okay. There's probably another way, but let me look at how he did it. So 24. So you know how? Oh yeah, he split it that. Okay. So this is how I would do it. So you have x squared plus x plus 3, right?
Yeah.
But then you can't just split it as like b over x squared and then have two terms. You have to split like one a over x, which is just one term, and so that you can account for that term, and then b over x squared. It's just like a rule, and then finally you have the c over x plus 3. Does that make sense? Because like the one we did before this, it was just okay. You have two things being multiplied,
Mm-hmm.
and then you just split it that way. The reason why is because you didn't have an x term, and then you can't account for that unless because like, every time you have an x term, like two different powers, uh, you have to account for not just the x plus 3 and the x squared. You also have to account for the x.
Okay.
Does that make sense?
So you're multiplying by 3 terms.
Yeah, like every time you have something like an x and an x squared.
Yeah.
The other one we didn't have that. We had like x squareds like for all days, right? It's only x
Mm-hmm.
squared. So
Okay.
you didn't have to account for x. But this one you had x squared and x. Like if you think about it, like you have like x squared times x and an x squared and an x plus 3, right?
Yeah.
Yeah. So yeah, like every time you see like the different like two different powers of a quantity, it could be like x plus 3 squared and then x plus 3, or it could be just x squared and x. You have to account for like that third term. So yeah, so how I would do it is I would split it as like b over x squared plus a over x plus c over x plus 3.
Okay. And
Okay,
then
so
multiply by
after you do
x
that, what's
squared.
the next thing?
You multiply by x squared times x plus 3, right? On the other side.
Yeah, so you take out the fractions, pretty much. So you want to make them like you want to get rid of fractions. Bx squared plus a over x plus c over x plus 3, and times it by x squared x plus 3. And so it's x squared plus 8x minus 3 would be cx squared plus ax plus 3 plus b x plus 3. Oh, no, ax times x plus 3 and then b times x plus 3. Let me know what you get for your coefficients. And then you solve for that. So minus 3 equals 3b. And 8 equals 3a plus b. and 1 equals a plus c.
Okay, and then B.
Yeah, this one I think it's just the theory of like splitting it into 3, like ABC instead of just AB.
So I have A plus C times X squared. Then I have 3A plus B times X.
Okay.
And then plus B times like 3B.
Yeah, yeah. What do you get for your ABC? It's pretty much just setting it up. Once you set it up, you get the
B
right
does
term,
B
right?
equal -1?
Yeah, B is -1. That's right.
Okay, and then
What about A and C?
does A equal 7/3 or 7/3?
No, it's a whole number.
It's a whole number.
Yep. Okay.
Oh yeah, 9. Okay, 3. Yeah, I
Good.
get it.
Yeah, it's 3.
Okay,
Okay,
and
so if
then
you have that, then you have C.
that's just -2.
Yep, that's correct. Okay, so that part isn't that bad, right?
No,
It's just the hard part right there is setting it up, like knowing what is the coefficient like form.
right.
But like I said, like the rule there is if you have like an x squared, or like a grouping of x plus 1 to the other power, and then you also have one that's not raised to that power, you always have to split it so you can account for that term. But if you only have like that same power, then you don't have to. Okay. Now you just pretty much integrate. This one you also use a u sub. Okay, so for my u, the one I'm trying to split is like the -2 over x plus 3.
Okay.
So you for my u, I got like u equals x plus 3,
Yeah.
and then du is like dx. So what do I get? So this one's not bad. So now you get like -2 over u du. So that one is -2 ln u, or like log u. At this point, you probably could just like plug it back in. So it'll be -2 log x plus 3. That's the first term. And then I think the next one I want to solve is this 3 over x one. So 3 1 over x dx. That's gonna be 3 ln x or log x. And the last term, -1 over x squared. So I think you could solve this one too. You don't have to do anything special. This is just 1 over x. And you put them together. All right. How did this go so far?
This one was pretty nice.
Yeah. Yeah, the next the hard part is just getting the hang of partial fractions. Do you want to do more of this one, or I think what I was gonna do is for 30, like not now, but like for later on, 32 to the rest of it.
Yeah.
Yeah, I kind of like in my mind, like if I were to study for this, I would study up to 31, and that like do most of that, like especially 14 to 31. Like, there's a lot of problems in the book. Do you have the physical copy?
Yeah,
So
I
far?
have the leaf bound.
Okay. Yeah, like I would look in the book, look for similar ones, practice like categorizing them, and then knowing how to attack each individual like method of integration. And then like um I guess, do you want to do a second one? Maybe like, I think how I was thinking about this, like maybe tomorrow. Like, are you free tomorrow?
Yeah, I'm free tomorrow.
Yeah, let's do like 32. I think the harder part is like 32, like all these integration ones, where it's like improper, the improper integrals.
Okay.
And then the 38 to 42. I think that's chapter 8. Did you have you done chapter 8 yet? Like, I think that's homework 5.
Yeah, no, that's homework 5. I haven't done that yet.
Okay. Yeah, let me take a look at that, and then like maybe I can solve like the rest of like homework. Oh yeah, how's the quizzes? I haven't had a chance to look at those.
Oh, I haven't been able to get them, but
Okay.
I've
How are they though? Are
they're
they
pretty
same?
much the same.
Oh, perfect. Okay. So anything homework problems, it doesn't get harder. Like, it's pretty much the same.
Okay.
Okay. So like what I was thinking, like let's do like homework 4 and 5 tomorrow, and like like the review problems. We'll do the same thing as what we did today. Kind of like similar problems to like homework 4 and 5.
Gotcha. Okay.
Okay. Did you still need like the solutions, or how do you I guess this is the first one, I was wondering what works best, like just doing the problems like like in hand, like like first, like just looking at it, or did you want me to give you like solutions and then we can discuss it, which way works better?
Usually what I do is like I work with them, like going through them and then like looking at the solutions afterward.
Okay, so like what so for tomorrow, maybe I'll give you the solutions for 4 and 5, homework 4 and 5, and then we can work on the review problems
Okay.
together. Cool. Does that sound good?
Yeah,
Okay. Yeah. Yeah. So I'm gonna book that for now. What time are you free?
pretty much all day.
Okay. Let me see. Tomorrow is Saturday. Okay. And I think I have an 11 to 12, and then a 4 to 5, 4 to 47. Okay, 47. What about like one. Oh no, that's not good. Are you free like in like what's your time? What's our time difference again?
2 hours.
2 hours. Okay. Maybe because I want to like get some time to do these problems. What about let's you want to do Sunday instead?
Yeah, that's fine.
Yeah. Yeah, I have like 3 people tomorrow. Like I want to also like give them some time. Um, so Sunday. What I have no one on Sunday. What about after 3? My
Yeah,
time.
that's fine. So 5 me. Yeah, that's fine.
Yeah. Let's do like 3, 3 to 5.
Okay. Yeah, that's good.
Yeah, it takes a long time. Like the same thing that what we did today, especially doing it like in hand. Like for just problem by problem. I think it's very effective though. What do you think?
Yeah, no, I like it.
Okay. All right. So yeah, Jacob. Yeah, I think this is good. I like the teams. I think it's. I mean, for me, what do you guys usually use for your class? I thought it was like Zoom.
No, for my school, we use Teams and Blackboard Collaborate.
Oh, that's the BB. I see.
Yeah.
Yeah. Hey, I saw like you guys have like multiple professors. I never had that like teaching each one. Well, how does that work?
Some of those are just problem sections and like just teacher assistants.
Okay, that's
But
why. See, I didn't know that. I thought they were like all professors.
yeah, no. Only like the only one that is a professor is my computer science teacher. He's an actual professor, but he's working with the actual professor.
I see. Yeah, I did watch that YouTube video. It's private, right? I couldn't even look for the other ones,
Yeah,
honestly.
no, I tried looking at it on somebody else's computer, but I couldn't find a way to do it.
And then you said like if you send me the link, it'll take too long.
If I sent you all the videos, it would be a lot of videos.
Okay.
I can,
I just wanted one sample because just and like I want to know how he teaches it. I see.
yeah, it's a lot of videos.
And it seems like it's pretty much the same. The way it's being taught for you guys is the same as, except for like like drawing stuff. Like honestly, like chapter 12, we had that too, but it was in the end, obviously. And
Yeah,
it's like basic stuff.
he said during the beginning of that lecture that like usually we do this during the end, but I want to do it during the beginning.
Okay, well at least you're done with it.
Yeah.
You can worry about the hard parts later on. Cool. Okay, I think it's on past then. Yeah. Thanks, Jacob. I think this was great. Let me book that for you, and then let me give you a Teams link as well.
Okay.
Cool. All right, man. Have a good night.
You too.